in problem number 3, when we're finding the domain of this function, we've got a couple of issues. But the first thing about domain is that this part of the logarithm must be positive. So when we set this up, it's going to be x plus 1 divided by x is greater than 0. The greater than part, remembers, means that it must be positive. So that's the domain part of that. So when we solve this, though, the second issue is that there's a variable in the top of the fraction, the numerator, and there's a variable in the bottom of the fraction, the denominator. So we need to eventually make a number line on this problem. And what we're going to do is we're going to take x plus 1, and we're going to set it equal to 0. And we're going to take the denominator, we're going to set it not equal to 0, because do we have a fraction? Do we have a radical? We have a fraction, and the denominator, the bottom of the fraction, is not allowed to equal 0. So we're going to subtract the 1 from both sides, and we'll get x equals -1. And I did want to write equals. I didn't mess that part up. But we're going to put these two values on our number line. So it's -1 and 0, and unfortunately, I see that those are very close together. But I'm going to pause the video for a second and pull up the calculator. So as we take a look at this on the calculator, when we type it in, we do not need to type in the logarithm. We just can type in the function. If you choose to type in the logarithm, you'll see errors in places instead of the negative, and that's okay. So we pull up the calculator, we're going to go into y equals, and we're going to type in alpha, window, nope, one more time, alpha, y equals, to get our fraction, and then it's going to be the x plus 1 over x. And we're going to go to the table here, because what we're going to be looking for is where are the values positive. So if we look in between -1 and 0, we're not going to be able to see that. So we have to change our table a little bit. And to change our table now, we're going to go to second window. And I always like to start at 0. But then I'm going to change the table to 0.25 to see a couple of values in between -1 and 0. You don't have to. You can change it to 0.5. That's always an easy one. But I need to see some values in between. So if we look now between -1 and 0, what we see in between all of those values is -0.333, -1, -3. We see negative values in between here. And we're looking for positive values. We want positive. So if we look before -1 and after 0, before -1, we see 0.2, 0.33, 0.42857. All of those values are positive, which is a value that we're looking for. And if we look after 0, what we see is we see 5, and we see 3, and we see 2.3333. Again, all of those values are also positive. So when we finish this problem, we're filling it in terms of number line. We want the positive parts of this. Something that I see I forgot to do is that it says greater than. These would have open circles on them. But what we end up then with our domain is that it's -infinity to -1 joined with 0 to 1.
Zero to infinity.
Sorry, 0 to infinity. 0 to infinity. He's right.
No, I think about that every single positive number
other problems that you'd like to see? 5. Let's begin in a couple minutes. Problem number 5. Suppose that f of x equals log base 2 of x plus 1 minus 3. And here comes domain again. And it says, well, what is the domain of the function? Well, when we're looking at domain, the part that we need to look at is this part right here. And it's going to be x plus 1 is greater than 0. We don't have to worry about the minus 3.
Why is that?
It's only this part of the logarithm that has to be positive. That doesn't have any impact on that part. So we subtract 1 from both sides. And when we do, we get x is greater than negative 1. And if I can write the correct interval notation this time, and it's not specific, I'm fine with that answer. But the other way is going to be negative 1 to infinity if we like the interval notation. And hopefully that wasn't the issue, but that was a good problem to look at. And I just now am realizing as I look back at the domain problems that I never did something exactly like that. So I'm really glad I did it on this one. But part B says, what is f of 7? So we're going to take 7 and we're going to put it back into our function. I'm going to erase this so I can see the whole problem. But we're going to put that value back into our function. So this is going to be log base 2 of 7. Putting the 7 back into the function for x plus 1 minus 3. So when we, when we figure out what this is here, I need to put an arrow to give myself a little bit more space. When we figure out what this is, this becomes log base 2 of 8 minus 3. Well, remember when we're figuring out what log base 2 of 8 is, if we just look at that specific part of it, what we did is we did log base 2 of 8 equals y. And then we went around the world. So we're going to get 2 to the y equals 8. And hopefully some of you know the answer, but if you don't, then remember our like basis. Kind of big. It's going to be positive 3 at this point, I think, Brett. But we get 2 to the y equals 2 cubed. 2 times 2 times 2 is 8. So then we have the 2's that we can ignore to get the y equals 3. So log base 2 of 8 equals 3 minus the 3 that's out here equals 0. And it says, what point is on the graph? Well, we put 7 into the function, and we came up with 0 out of the function. Depending on your calculator, that's one of those problems that you conceivably could have typed it in to the calculator if you did alpha window, is that right? I hit the window. Yep, alpha window number 5. And then we could have typed in log base 2 of 7 plus 1 minus 3. And sure enough, there's the 0.
Can you do that if you want us to?
I just want to point it out because some people know that technique, so I don't want half the class going in and going, oh, I can just type this in the calculator, and the other class going, oh, I got to figure that all out. I want everybody to have the same advantage on that. So, and I don't give very many of those.
But on the test, like if we just did that, would we get
Full
points
credit.
enough? Okay.
Full credit.
Okay.
So, and that isn't going to be the one that you're going to miss. It conceivably will be problem C, which I'm going to kind of try to write over here beside it. It says if f of x equals negative 1. we've got to put that value of -1 in the right part of our function. So f of x is the value of -1. We're filling in the f of x part of the function, so it's going to be -1 equals our log base 2 of x plus 1. And sorry, I can't fit that -3 on there right now. Let's see if I can scoot it over a little bit. -1 equals, and then we can put our -3. So then when we solve this problem here, we're going to have to move the 3 over to the other side. So we're going to add 3. And we get 2 equals log base 2 of x plus 1. And I'm going to do around the world. I am going to move my logarithm over to the left. You don't have to. But it's log base 2 of x plus 1 equals 2. Didn't change anything. I just put the logarithm on the left. And then we can go around. So we end up with 2 squared equals x plus 1. And then 2 squared is 4 equals x plus 1. And subtract 1 from both sides. So we get 3 equals x. But don't forget, on this part, it says, what is the point on the graph of f? Well, 3 is our x value. F of x is another way of writing y. And I believe we put in -1 in for f of x. Right, so I heard 10. Sabrina? 7? 6? So we'll start with 6 and solve each equation, leave answer in simplest fraction form if necessary. We are going to start with around the world. So we'll take the 3 and we'll go around. 3 squared equals 3x minus 2. 3 squared is 9. And then we're going to add 2 to both sides. So we get 11 equals 3x. If we divide everything by 3, we do get x equals 11/3. We do need to think about whether we have an extraneous solution or not. When we go back and test, it's going to be here in the argument part of the logarithm. This value must be positive. But 3 times 11/3 is 11. Minus 2 is 9. It's positive. And then technically on this one, yes, and that is true. But the important concept here is that when we put our potential answer back into the original problem, that value that I have circled must be positive. Well, 7, even though it looks like it's a completely different problem, it's still going to be an around the world problem. But the first thing that we need to know on this problem is, what is the base of natural log, of the ln? It's e. So if we know that our base is e, then what we're going to do is we're going to go around the world. So this is e to the 8 equals e to the -2x. We have common bases. So we can ignore the e's, and we we get 8 equals negative 2x. And we can divide both sides by negative 2, which gives us negative 4. We don't have to check for extraneous solutions so much because e in this part of the logarithm is already positive.
If I just said the ln e of
So, problem number 8. Once again, problem 6 was around the world, problem 7 around the world, problem 8 still around the world, and even if I look on problem number 9, it would be around the world. We're going to take the x and we're going to go up and around, so this is x cubed equals 1/8. Well, what's the opposite operation of cubing something? Cube root. So we're going to take the cube root of this on both sides. And when we take the cube root, you could type that in the calculator, but cube rooting and cubing, inverse operations, they give us x. And if you type that in, cube root of 1/8 is 1. Cube root of 1 is 1, cube root of 8 is 2. Number 10. Ready? So, it says e to the negative 2x plus 1 equals 13. This is the problem that I'm worried about. And it's because I ended up collecting in my afternoon class that first assignment, and people couldn't do this problem. So I'm worried about this one, but like bases. Always think like bases in terms of solving this. But we can never turn e into 13. We can never turn 13 into e. The only thing that we can do is we can put a natural log into both sides. Natural log, because eventually we're going to get to the point of finding natural log of e like we could have done on problem number 7. But this is natural log of e to the negative 2x plus 1 equals natural log of 13. Now that we put the natural log in, we can take that exponent using our properties, and we can rewrite that exponent as a coefficient. So we still have natural log on both sides. But now we have the negative 2x plus 1 over here, natural log of e equals the 13. Well, when we type in natural log of e, and it might still be on the calculator here, natural log of e is 1. So just to make sure you know how to type it in, I did natural log, and then I did second and the division sign, and then we type it in, we get 1. I recommend that you don't skip steps on this. Natural log of e is 1. And then we have the negative 2x plus 1. And over here, we still have natural log of 13. So negative 2x plus 1 times 1 is negative 2x plus 1 equals the natural log of 13. And now we can solve this problem. We're going to move the 1 to the other side. We're trying to solve for x. So we're going to move the 1 to the other side. And we get negative 2x equals the natural log of 13 minus 1. Remember that natural log of 13 is some big long decimal. We cannot subtract 13 and 1. It's separate. And then the last part here is negative 2 times x equals that value. So we're going to divide both sides by negative 2. And we end up with x equals natural log of 13 minus 1 over negative 2. On the answer sheet, I probably did not write an answer with the negative in the denominator. But what happens is we can make the negative 2 positive if we change the natural log of 13 to negative, and we change the 1 to positive. And I might have even written 1 minus natural log of 13 over 2. But this is the exact answer. If we want it in the decimal format, which all we have to do is type it in.
Wait, what was the exact answer?
Either one of those. So that's the exact.
So if we left it with the negative 2, would that be wrong?
It's not. That's not a big issue to me. William?
Could we do 17?
Yes. Still looking at 10 here. So as we flip over to 17, more of the properties. Uh-oh. There it is. A couple things that we need to look out for. Do we have a number in front of the logarithm? No. Do we have an addition or subtraction in here? Yes. What does subtraction tell us to do? Tells us to divide. So we're going to take log of 5x plus 3 divided by x minus 1 and set it equal to 2. Another thing to really watch out for on this problem is that there's a logarithm on the left side of the equation, but there's not a logarithm on the right side. What's the base of a logarithm when it's not written?
10.
It's 10. We need to know that. And because there's a logarithm on the left and there's not one on the right, we do need to go around the world. We'll take this value and go around. So we convert, and it's going to be 10 squared equals 5x plus 3 divided by x minus 1. Well, 10 squared is 100. 100 equals 5x plus 3 divided by x minus 1. And we're trying to solve for x. So we need to get that x out of the denominator. We're going to multiply by x minus 1 here. And we're going to multiply by x minus 1 here. And our x minus 1s will cancel out. So now we get x minus 1 times 100, and you might have skipped this step. But I'm going to distribute. Distribute the 100. So 100 times x. 100 times 1.
Negative.
Sorry. But 100 times the 1, keeping in that negative symbol or the minus symbol. And now we can solve. So we're going to combine the x's. We're going to combine the constants. And we end up with 95x equals 103. So not the prettiest of answers, it looks like, but it'll be okay.
No, divide everything by 95.
Divide everything by 95. So there we get a value. But we also need to, at this point, check for extraneous solutions. And that goes back to the domain. We're going back into the 5x plus 3 part of the logarithm, the x minus 1 part of the logarithm, and we need to make sure that when we put this value in, which is a little bit more than 1, put that back back into the problem here.
Well, as long
that
as
guy's
X is
positive.
positive there, good. That one, as long as literally above 1 is good. And it's
It's
positive.
true. Okay.
Oh, never mind. Keep doing it again.
Okay. So if we put our value in again, the 103 over 95. So positive 5 times positive 103 over 95, it's going to be a positive number.
Plus 3.
And then we're adding 3 more to it. So positive plus a positive is positive. You could even type that in if you want an exact value. But what Rhett and I were looking at as well is that 103 over 95 is a little bit more than 1. 95 over 95 would be 1. So we have a top-heavy fraction. It's a little bit more than 1. So a little bit more than 1 minus 1 will still give us a positive value, which means that 103 over 95 is our solution.
It's basically microscopic. That's there.
Kat, are you okay?
Uh,
Are there others? Kat?
Either 13 or 15.
All right. I was thinking that I was not going to get out of here without doing problem 13.
I'm doing it right now, like again, and I still I got X equals 78.
So, on this problem, we've got to watch out for this 2. Did you deal with that first? It's 2. So we're going to take that 2, and we're going to make it an exponent. So this is log base 3 of x plus 4 squared minus log base 3 of 9 equals 2. Second thing, we have a minus in the problem. What do our properties tell us when we see a minus? We need to divide. This is log base 3 of x plus 4 squared divided by 9 equals 2. Third thing to look at here is that we have a logarithm on the left side. We do not have a logarithm on the right side, and that means that we need to go around the world. We take this 3, we're going to go around. So we get 3 squared equals x plus 4 squared divided by 9. So now we've dealt with the logarithm part. We still will have to deal with extraneous here in a couple of minutes. But 3 squared is 9 equals x plus 4 squared divided by 9. And let's get that 9 that's in the bottom of the fraction, the denominator, out of there by multiplying this side of the equation by 9 and this side of the equation by 9. So the 9s cancel out here, and we get 81 equals x plus 4 squared. Well, last week in our notes, we did one of these problems here. We could FOIL it out, but there's an easier technique. If you recognize that this is squared, and 81 is also a square. It's 9 times 9. If we take the square root of both sides, we get plus or minus 9. Because 9 times 9 is 81, but negative 9 times negative 9 is still 81. And then over here, square rooting and squaring cancel each other out, is x plus 4. So now we have to solve this equation, but it's a little bit easier than factoring. We have 9 equals x plus 4, and negative 9 equals x plus 4. Are you kicking yourself, William?
Well, no, I'm already kicking myself over the mistake that I made earlier,
Oh,
which was I apparently forgot about the whole around the world to get rid of logarithms.
and that's a big thing. Don't forget the around the world when you have a logarithm on one side and you don't have it on the other. So we're going to subtract 4 from both sides. Here we get x equals 5. Subtract 4 from both sides here, we get negative 13. And granted, we have more of a chance that negative 13 is going to be extraneous because it's negative. But our answer is allowed to be negative. It's when we go back into the original problem, will it be negative? And looking at this negative 13, since that was what we were just talking about, that value needs to be positive. But negative 13 plus 4 is negative 9. So negative 13 here is extraneous. But our 5 here, 5 plus 4 is 9. That is a positive value. So our solution is 5.
Is it possible to ever get two answers in the logarithm?
2 answers for a logarithm?
Yes.
Yeah, I mean, look at problem number 14. We did. But let's look at problem number 15 here. Because it has log base b. But the key on this is there's a log base b in the first term, there's a log base b in the second term, and there's a log base b on the other side. We don't need to know what the bases are. We just need to know that the bases are equal. So we've got a minus in this problem, and what do our properties tell us when we see a minus? Well, they tell us to divide. So it's going to be log base b of x squared minus 3x divided by x equals 3. And it might be nice if I wrote my log base b over here. Log base b of 3. But the difference on problem number 15 compared to 13 and compared to 17 that we've just done is that there's a log base b on the left side and there's a log base b on the right side. We're not really canceling them out. We just don't need those values to solve. So what we have left is we have x squared minus 3x divided by x equals 3. And let's get that x out of the denominator. We're going to multiply this side of the equation by x and this side of the equation by x. And when we multiply them, we're left with x squared minus 3x equals 3x. Well, let's move the 3x over to the other side, and by saying move the 3x to the other side, I'm going to take our right side 3x and move it over here to the left side so that we can factor this problem. So we get x squared minus 6x equals 0. And then when we factor, we're factoring the greatest common factor. And now what we have x equals 0. And x minus 6 equals 0. And we need to go back and check for extraneous solutions. We're going back into that part that we look at when we're looking at domain. That's the part that has to be positive. It really does go back to domain. And we're looking here. This value has to be positive, and this value has to be positive. Our first value that we have is 0. Well, 0 squared minus 3 times 0 is 0. Is 0 positive?
No.
No.
It's negative or positive.
Correct. 0 is neither negative nor positive. So we're going to say 0 is extraneous. But hopefully 6 will work. And 6 squared is 36, minus 3 times 6 is 18. 36 minus 18 is 18. Is 18 positive? Yes. And over here, the 6, also positive, so our solution to this one is 6. Others that you'd like to see worked? So the pH problem. What's the pH of the solution for which the hydrogen ion in 10 minutes or so, 7 to 10 minutes, on number 11. All we're doing on part A, and I know I didn't read the problem, but we're going to take 0.001 and we're going to put it back into our function. Where we see hydrogen ion. So instead of H plus, let's put in 0.001 and let's type it in. So if you have a regular TI calculator that has this screen up here on the board, then we can even use this button, log, except that I need to type in first of all negative log, because this button, LOG on our calculator, is base 10, and it's 0.001, which gives us 3. Not the issue. You probably didn't have any trouble on that one. It's the next part here, which gives us the pH value, and we need to figure out what the hydrogen ion is. So it's 3.1 is going in for our function, equals negative log base 10 of the hydrogen ion. Well, in order to solve this, we need to get that logarithm isolated. And right now it's negative times the logarithm. So we'll divide both sides by negative 1. And now we have log base 10 of the hydrogen ion equals negative 3.1. There's a logarithm on one side of the equation. There's not a logarithm on the other side. We're going to go around the world again, and I'm not going to rewrite it. I'm starting to run out of time here. But we'll go this way when we convert. So we come up with 10 to the negative 3.1 equals the hydrogen ion. And we can type that into our calculator. 10 to the negative 3.1. And we get that big old decimal. But if you're looking at the directions, what it says is it says round to 6 decimal spaces as needed. We don't want this problem in scientific notation like you might in chemistry. We're doing the math behind it. So what this means here is this means 7.943 times 10 to the negative 4. That's what that E times 10 to the negative 4. And then we're going to move our decimal place. Well, we're going to move it 1 space, 2 spaces, 3 spaces, 4. So when we fill those in, we're going to have 0.000794.
Heaven forbid there ever be any overlap